Hey, 6th graders, Mrs. Treville here with a little bit of help for your March 1st homework. I'm actually going to look at the second problem. It's got a lot more words and there's a lot more going on, right? So if you're looking on the PDF, you can zoom in and you can see this carnival game. So I've gone to a few carnivals, and the way this game works is you pick up a duck, and if there's something written underneath, you win a prize. Right? So you don't get to look underneath until after you pick it up, and you have to pay money to pick up a certain number of ducks. Right? So that's the carnival game. This carnival game with the ducks has 160 rubber ducks floating in the pool. The person playing the game only gets to take out one duck and look at it. If there's a red mark on the bottom, the person wins a small prize. And if there's a blue mark on the bottom, the person gets a large prize. And then notice the next sentence. Many ducks do not have a mark. So if you pick up a duck that doesn't have a mark, you don't win anything. You're just out of luck. All right, the next sentence down here says 50 people have played the game, but only 3 of them have won a small prize, and none of them have won a large prize. So that's a decent number of people who've played the game. Down in the bottom, it says, I think blank of the 160 ducks have a red mark on the bottom. I think blank of the 160 ducks have a blue mark on the bottom. All right, so there are quite a few ways to think about this. I'm going to write a fraction for what we already know has happened. Out of 50 people, 3 have won a small prize. 3 small prizes. And, put this maybe on the other side, out of 50 people, 0 have won a large prize. So what does this tell us? There may or may not be any ducks in here that have a blue mark for a large prize. I think it's actually illegal for them to market a game where there would be 0 ducks in there with a blue mark for a large prize. So it's probably not 0, but it's probably a really small number, all right? So if 50 people have pulled a duck and there are 0 large prizes, right, then I would expect with 160, there would be so few blue marks. Maybe it's like 5. Maybe it's 3. Right? Maybe it's just 1 and this game is almost impossible to win. But that should be a really small number. I think 5 is a pretty good number there. But for the red ones, I already know if there are 50 people, it's 3 small. So if there were 100 people, if it was 100 people, I'm going to write, 100 people, or maybe we could call that 100 ducks getting pulled out. So I'm going to change that to out of 100 ducks. If that's twice as many ducks getting pulled out, then maybe it would be twice as many that would win. Maybe there'd be 6 small prizes and 100 ducks. So if there were 50 more people pulling ducks, that would now be 150 ducks. That would be 3 more small prizes. So that would be 9 small prizes out of 150 ducks. So now I'm going to compare these numbers and say, okay, 150 is pretty close to 160. So maybe if there were 10 more ducks pulled out, maybe that would be 1 more small prize. So I think there are maybe 10 of the ducks have a red mark on the bottom. Right? And these are my guesses because you'll have to fill this part in, right? So we tripled the number of people who've played and got 150, right? And then we added 1 more. So that would be a good reason for the red one. And for the blue one, nobody won a prize in 50 pulls. So probably there's not very many ducks, right? Again, it's got to be more than 0 because otherwise they would get in trouble, right? But it doesn't have to be very many more than 0. Okay, For the first problem, right, flipping a coin has a probability of 1/2 of landing heads up. Somebody flipped the coin over and over and over 10 times. It landed heads up 3 times and tails up 7 times. So the probability that Lynn has right now of getting heads up is 3 in 10. 3 heads out of 10 flips. So the question is, has she proven that the probability is really not 1/2, but it's 3/10? And explain your reasoning.